Hi, I'm Tim Lindquist. I'm a professor in the software engineering program at ASU, and this is a video that supports our course in mobile computing, Ser423. Today we're going to be talking about the navigation and lists in Android, which is Unit 4, the material in Unit 4 and the examples that go along with it. The resources and the readings appropriate for this in the Murphy textbook. There's a section on adapter views and adapters, and then there's a tutorial that goes along with that, as well as the section in Murphy on adding an action bar. Actually, by default, you get action bars now. And then an Android developer designing effective navigation. All right, so this is talking about the different ways that you can navigate. So the idea is with all apps, not all apps, but with most apps, there's more than one view that are involved. Right? There's information that has to be displayed and or entered, and commonly it takes several views in order to do that. How do we move from one view to another view and correspondingly move from one activity to another activity? The way that it's done on the different devices and different platforms differs a little bit. In the mechanics to make it happen, it differs significantly, but in the guidelines and the design for the apps, actually it's not that different. So in Android, we find that the action bar is across the top of the app, of the view. That action bar commonly contains buttons. Let's see if I've got one up here. Yeah. A menu in the action bar. In this case, the menu only has settings, but then there are also buttons that are common. So I think if we look at any one of the details here, there's a back button in the action bar in this particular app. We're going to take a look at this app in a little bit of detail here in a couple of minutes. And then another app that we're going to look at, let's see if I can find it. For Android, simple adapter, I think that's the one. So it may be difficult to see it in the video, but in this case there are three different icons across the top. There's a back button, there's a delete, and there's an add button. So it's very common for the action bar to have buttons. Those buttons may imply navigation, moving from one place to another. And they may also imply actions that take place on that particular view. So in this particular case, the back button takes us back to a previous view. So in Android, it's actually the action bar. The action bar can be made into have tabs. In iOS, it's a little bit different. The tab bar is across the bottom. Remember, in iOS, there's only a single home button instead of having the three buttons that we have in Android. A tab bar goes across the top, and then there's something very similar to the navigation bar in iOS apps, similar to the Android's tab bar, which is called a navigation bar in iOS. So today we're going to look at exclusively Android, and we'll look at the way of doing navigation in Android. And also we want to focus on adapters and the composite controls that require a data source or an adapter, as it's called in Android. So in Android, whenever you have a list, this is an example of a simple list. In other words, there's a row in each element, or in each a list of rows. Those rows may have multiple columns in them, but there are a list of elements, of rows of elements. We can actually have specific headers that may be different views. I didn't do that, but instead the header is actually like one of the rows. And we can do the exact same thing in iOS. In iOS, it's actually called a table view. and we'll take a look at that table views in the next section as well. So we're going to look at the basics of navigation, going from view to view in Android today, and we're also going to take a look at the adapters and having lists, both expandable lists and then also these simpler lists, and how the data gets provided to the list object itself. So that information on Android, this section actually goes through looking at screens, how you go about laying out and storyboarding your Android app, planning for multiple touch screen sizes, providing for descendant and lateral navigation, right, burrowing down into an app, burrowing down into the information, going further and further into detail by going to different views, and then lateral navigation, kind of swiping type of view, looking at extending the information that I currently have provided on one activity. So Android and mechanisms for working with Android is our goal today. So there's other actually good links. I think one of these on different patterns for dealing with data. This is Android Patterns. That is a website that actually shows common practice and guidelines for developing Android apps. There are some links to code here, but more than anything else, it just kind of shows you screens. If you kind of burrow down, you can see each of the different kinds of organizations that can be used, right? So here's 3 up here as a tab view as part of the action bar, and then you can see pickers that are used as well as other kinds of layouts. So screen interactions, we're going to actually look at the list items is a particular thing that we're going to look at today in Android. And moving, all right, so the idea is we've got one list on one view, and then by selecting one item in the list, we want to find out more detail about that particular list item. So that part of navigation, being able to pass data from one view to another view, we're going to look at the basics for doing that in Android. Now in the so this is Unit 4 on Android navigation and lists, and there is associated with it, there's 1, 2, 3, 4 different examples. I'm going to go through, probably we'll get through 2 or 3 of them. They're all together in this droidnav.jar file, or depending upon whether or not there are changes, you'll find them linked from the samples part of this Unit 4 on more composite or collection type views. So let's go ahead and take a look at that. Let's actually go into, I think the first one we're going to start out with is the simple adapter, and that simple adapter is what's used for simple single lists. And so I'm going to go into the project. It's actually out of this jar file. Let's see which one we want to go to here. Simple adapter list, and kind of go through it. So this is Android Studio. I've already extracted it and opened it up. There are actually 2 different activities in this app. Main activity, let's go back and look at here it is right here. So in the main activity is nothing more than a list that, it's supposed to do that, but I guess it's not going to do it. Main activity that lists all of the students that we have, and then if we select one of the items or one of the rows in that list, it takes us to another activity that tells us all of the courses that that student is taking. All right, so going back and forth, these are actually 2 different activities. So if I select Sally Smith, she's taking CSE 445, CSE 110, and SER 423. And James Jensen is taking CSE 110 and SER 423. All right, so let's take a look at how we provide information to those lists and set up those lists in a sample application. Before we actually take a look at the layouts for them, let me just talk a little bit about the underlying data model. We've got a course class, and the course class does nothing more than wrap the prefix for a course and the title for a course. So the prefix Ser423 and the title mobile computing as an example. And it has the ability to create a course object from a JSON object. So we're going to look at JSON throughout this course as a way of serializing and deserializing. Why use JSON instead of the built-in serialization? Well, in this case, we're actually using both, but JSON is a very convenient and terse mechanism for actually storing in text form and sharing it among different programming languages and different programs. So that's a course, and so we have students, and students have a name, a student identifier, and I go up here to the members. The name is a string. The student identifier is an integer. Can actually boost this up a little bit to make sure it shows up all right. Student identifier is an integer, and then we're going to have a vector or an array list of takes, which is a vector or a collection of courses that a student takes. And then the constructors that support it. Actually, I think these things are all public, so they can be directly accessed instead of having getters and setters. Kind of take a shortcut sort of approach just to make the code a little more concise. And then the ability to go back and forth to and from JSON. So I'm not going to read all of that stuff. Here's the JSON that's used to initialize the model. All right, so for each student, this is what's called a JSON object. I'll kind of explain JSON a little bit to you anyway. So a JSON object is something that's contained within curly braces, right? So JSON is a text form for serialization. So curly brace is the delimiter for each side of a JSON object. And each element in a JSON object consists of, so here's one of the elements in this JSON object. There are two. Right, so this is a JSON object for a course object representing a course. So each of these two components within this JSON object has a key and a value. So in this case, the key is prefix, and the value is the string Ser423. And then the title key has a value in this case of mobile computing. All right, up above, we have a component of another JSON object, which is representing a student. A student has a name, that is a string. A student has a student ID. All right, so the key student ID, and in this case, it shows you another type of a JSON component that can exist, and that's just a regular number. It can be a floating point number, an integer number. Either way is fine. Notice that there aren't any quotes around it. If there were quotes around it, then it would be a string that has 50. As it is, it's actually a number. And then the other form of a JSON object is an array. All right, so an array is started off with a square bracket, and it ends with a square bracket. So everything from what you see in blue up here after takes, all the way down to the blue after language design, is an array. These are the components of the array, and in this case, the array is an array of 4 course JSON objects. All right, so that shows you almost all of the different types that exist within JSON. There's string values, there are numeric values, there are JSON object values, and there are array values. There's a null value as well, and that probably covers all of them. So this whole thing is a JSON object, meaning that there's a key, and the key is the name of the student, and the value associated with the name of the student is the JSON object that represents the student value. So the program is written, each of the classes are written so that they can read in this JSON string and then build, in this case, 4 different students from this JSON serialization of what the values are for a student. And if you read, which I hope you will, because it'll be helpful if you implement the exercises. If you read the code in course, student, and student collection, you'll see that that's how this gets read in, and the student collection, which is a collection of student objects, and the student objects, one of the components of it is a course, how that gets built. All right? In student collection, there is an initialization that is done actually by calling, well, it actually goes and gets the, sets up a hash table and then calls this internal method reset from JSON file. Reset from JSON file goes to the bundle, creates a, open raw resource, raw students, and that is our students.json file in the raw directory of resources. Creates an input stream, a string buffer, and then it essentially reads everything from that file into a single string, and then uses the JSON org.json classes. JSON object is one of them, JSON array is another one, in order to parse and to create this student collection. So I'll let you take a look at that code and play around with it, but you'll see that it creates for me a model that consists of several students. So that takes care of those three classes, the course class, the student class, and the student collection class. The other two are controllers. Main activity is the controller for the launch activity for this app. And the launch activity is the one that you see right now in the emulator. It actually has a list of students that shows each of the different students, and then, so you can see James Jensen, James Burton, Jimmy Buffett, and Sally Smith. Those are all of the students that are contained in that JSON file. So when I select one of them, I actually go to another activity. So the main activity is what we were just looking at. We are now looking at the student display activity, which displays the courses that displays all the information about a student. Student Sally Smith with ID number 105 is taking, in this case, these three courses. Okay, so let's look at how we go about setting up the layouts. Both of these views have a list view. So actually the layout files for both of them are very straightforward. I have a text view, which is essentially a label. So I'm looking at the main activity right now. Notice that it is a relative layout, and I'm laying it out so one's below the other. All right, layout below. So my list view is below the student text view, and this is the student text view. And that's all I have to have in my layout, just one text view and one list view. We'll see how the list gets populated. The list can actually grow very large if we want it to. And then the other one is the course list. I'm sorry, that's the list item. Student display is the other layout. We'll see how these course list and student list items come into play. So I thought it'd be a good idea to show you the difference between a linear layout and a relative layout. So this one uses a linear layout, and the linear layout is organized in the following way. A linear layout can either be vertical, its orientation can be vertical, which means that it takes all of the components I put into its subs and it makes them vertical, or the layout can be horizontal, right, going across the view. And in this particular case, I've got one of each. Vertical says that I want to use up all of the vertical space within my view. First is a linear layout. All right, so that's essentially going to be defining the first row of my layout, and then below it will be a list view. So you'll notice when a linear layout is used that you do not use relative positioning. So I don't say that one control appears below or above another control. I simply let them go into the order in which they occur within that linear layout. The order in which they're nested within the layout indicates where their positioning is relative to the other ones. So two text views in a horizontal layout provides for me with this. It's really hard to see it there. It's probably less hard here. But student Sally Smith with ID number 105 is taking, right? Well, that's actually two different text views. We'll see student Sally Smith is one of them with ID number 105 is the other one of those text views. They're laid out horizontally. And then that linear horizontal layout is followed in a vertical layout with a list view. Okay, so those are the view serialized versions of the views, the layout values for them. Let's go ahead and take a look at the code that actually populates each of those values, and it's actually a little complex, but we'll kind of hit the highlights of it, I guess the right way to put it. So here's my main activity, and notice that in this case I'm actually implementing an interface, a Java interface, and this interface is on item clicked listener, and it's the on item clicked listener defined for a list view. All right, so that provides the ability for me to have specific actions that occur when the user selects one of the students. All right, so I'm looking at the main activity. That's the activity that is the controller for this view, the student browser view. And when one of the rows is touched by the user, it will cause an on-item click event to occur, which will call the method that is provided in this class. Okay, so here are my, that's my model, student collection, a collection of students. This is going to be my list view. All right, that's the list. And then these are the elements that are used in order to fill up that list view, and we'll take a quick look at how that works, and then we're going to go on and take a look at another example. Pardon me. On create, I expand activity main, and then I pick my list view out of it. Student list view is the list view component of it, and somewhere here I must pick out the set title to student browser. Oh, right, the student, this one does not have a specific message up above. I'm looking at this guy right here. Student list, right? So it just says, here's the list of students. I don't have to have that within the controller. I'm not changing that text view. Okay, so I set up the students, student collection, so that goes out to the JSON file and reads all of that stuff in for me and creates each of these different students, and I can access them through this student collection object. I then prepare the adapter. So what's adapter? Well, an adapter is a data source. When I have a list view, the view is empty. And what I need to do is to create rows for that list view. The way that rows are created on both platforms, both iOS and on Android, is by implementing an adapter. And that adapter provides a set of methods that the control calls. All right, so the control, what's the control? Well, this thing is the control. The list itself is a control, and it comes to my code and says, how many rows do I have? Okay, I've got 5 rows. What's in the first row? What view should I put into the first row? What view should I put into the second row, and so forth. So each time that the list needs to repopulate itself, it calls methods that I define, that my app defines, and I provide the implementation of those methods. The app developer provides the implementation of those methods so that the list view knows how many rows it has and what's going to be in each of those rows. So not only is it the information, is it the data that's contained in the row, but you'll see that for both platforms, it can be a view. All right, so it can be a collection. So if I wanted to, each row of my view, each row of my list could be a linear layout, or it could be a relative layout and within it a linear layout. So it can be a complex view that contains anything that I want it to. So I could have a list row that took up half of the screen if I wanted it to, that was made up of images or icons or anything else that I want, together with text. In the same way that I can design a layout for an entire view, I can make each row within a list be a complex view, a nested view. And even more interesting in that, a single list may have a different view for each row. So it may be that in one row of your view, of your list, you may want to have a very large, or maybe have an icon, or have an image, a PNG that you want in that view, and another one is all text, and you can certainly do that as well. So the simple adapter is the mechanism for doing that, and here's the method for prepare adapter. So this .prepare adapter. And what it does is to set up labels, labels for the columns, which is an array. Android has the ability to define string arrays in a more efficient way than is typically done in usual Java code in the values. So here's an example of a string array, actually two different string arrays. One of them is called identified as column header. It has two different values in the array. Both of them are strings. So the first value in the array is first, and the second value in the array is last. And then also another two-element string array that has prefix and title. So I can make the access to those much more efficient, the strings that are actually placed in them, much more efficient by putting them into a value XML file, which is called array. This example app shows you how to access those from the prepare adapter. All right, and the way that we get that is this, meaning this activity, get resources get string array, and then give the identity for it. R.array, right? R is our generated class. I have an array resource, and within that array resource, I define an array with an identity of COL underscore header, and that is COL underscore header is the first of these two arrays, the one that's now highlighted in dark blue. All right, string array whose name is column header. Okay, so as I prepare this adapter, I need an array of labels for the columns, and I also need an array of IDs for the text views. In this case, they're going to be text views that are used within each row of the array. So I said that lists, rows in a list can be views. So that view in this particular case, so this is my student list. I have a student list item layout. So here's the student's first text view and the student's last text view. These are the identifiers that are defined in a linear layout. So this lays out one row in the list with a fairly simple layout that only consists of two text views, so that each row within this list has two text views that are laid out in a horizontally positioned, oriented, linear layout. All right, and that prepare adapter is actually providing the information for the data source to give the adapter what it needs in order to create the create the list itself. So then here's the student names. This is a string array of all of the students, and then titles gets placed into a hash map, and then fillmaps.add. So fillmaps is my array list. This is the format that's specified by this simple adapter. It's called a simple adapter, but I can guarantee it's going to take a half an hour reading on your part in order to figure out what's going on in here. But what's happening is that we are creating this fillmaps array list where each element in the array list is a hash map. And that hash map is telling what to put in each of these different components. So fillmaps.add titles is placing a hash map for the first row. All right, so the code that I currently have highlighted is the code that essentially puts in the data source for the first row, which is first and last, which are the column headers. And the iteration creates more hash maps, creates one hash map and throws it into fillmaps for each row, each student in my collection of students. All right, so this is the preparation, right? Preparing the data structures that are necessary in order to create the adapter. The adapter is actually created right here. Simple adapter SA is a new simple adapter. You may not think it's so simple, but actually once you play with them a little bit, they do become fairly straightforward. That provides all of those data structures that we defined in the prepare adapters as part of it. r.layout.studentListItem is referring to my layout down here for the row. Each row is going to be a student list item, and then the column labels and the column IDs provide the IDs within that layout. Okay, so then I set my student list view, its adapter to this simple adapter, and then I say set on item click listener to this. So let's move on. The other thing I want to point out is how we move, right? We have not looked at an example yet of moving from one activity to another activity. And in this particular case, not only are we going to move from one activity to another, but we're going to pass information as well. And that's what comes next. So I set the adapter, which causes the adapter to populate itself with all the information provided by this prepare adapter. And now set on item click listener says I want to call the method on item clicked each time that the user presses on one of these rows within the list. And let's take a look at what happens in that case. Okay, so the idea then is on item click gets called when the user selects one of the rows in the list view. And what we want to have happen in this case is for us to go to another activity. Right? We're right now in the main activity. What we want to do is to go to display the information about a given student. What courses does this student take? And what's their student ID and their student name? Well, in order to do that, we need to pass information to a new activity, and we need to cause a new activity to start. And the Android, not the only way that you can create a new activity, but the most common way to create a new activity in Android is to create an instance of what is called an intent. We use intents in Android not only to create activities that we define in our own app, but we can also use intents to create activities that are defined in other apps as well. In other words, you can advertise, here are the intents that my app will recognize. In this particular case, we are creating an intent, we're going to call it display a student, which is of the class student display activity.class. All right, so when I start this intent, or when I send this display student intent a message that it's supposed to start, it will cause the student display activity to start up and to display the information in its corresponding view. However, I want to send it some data. And in this particular case, the data that I can attach to an intent is in the form of a map. In other words, there's a key and then a value. And I can include, if you go and look up an intent and the put extra methods that are defined in the intent class, you can see I put any kind of basic Java information into an intent, or I can put in something that is serializable. And that's what I'm doing in this particular case. Student names so this select students is actually the entire collection of students. All right, so this students right here is the students that's defined up here. Students is a new student collection. Well, a student collection is my whole collection of students, which are all of the things inside the student collection, which is a hash table, and you don't have to worry about the static, but that hash table is a hash table of keys where strings and values are students, but students, student objects are made up of a string name, an integer student ID, and then in this case a vector, or it's actually a synchronized or a thread-safe array list of courses. All right, so I've got three classes that are involved. I've got a student collection class, I've got a student class, and I've got a course class. Notice that for all three of those classes, they're serializable, which means that I'm using not only JSON in this example, but I'm also using Java's built-in serialization in order to pass data using an intent. All right, so here's back to my intent. So display student, the intent, put extra, the serialized form of the student's student collection, and then also a string. And that string is the name of the specific student whose information is to be displayed. So I do put extra into the intent, and then I say start the activity for a result. So there are different forms for starting an activity. The one that this is being demonstrated here is that I know that this activity is going to do something and then it's going to return to me. I may actually want to, when it returns, I may want to get some data from it. All right. So for example, it doesn't happen in this app, but suppose that the activity that I'm starting makes a change to the data source. All right, makes a change to students. Well, I may want it to pass students back to me in a modified form. Maybe a new course gets added, or maybe the student ID number changes, or maybe the first name changes, whatever. So I can also have in my calling activity an on-activity result. That on-activity result will be called when the called activity finishes. That's kind of complex, but when student display activity executes the finish, what happens is my main activity will again come into view, and I will, before it comes into view, I'll have on activity result be called, which allows me to make any changes that I need to make to my adapter, so that if there's new students or whatever, they will be displayed properly in my view. Okay, so that's the way that we make a call to another activity. We're definitely not going to spend as much time on the display student activity as we did on this one. Just to point out, so it has a list view as well, and the other thing that it has is menu items. So in create, you can see we use the exact same thing, preparing a simple adapter. The method is almost exactly the same, except now we're looking at courses instead of looking at student information. You can see I pick out the list view, I pick out the student name and text views, and so forth. And the main thing here is to get the intent. So how do I know what my collection of students is? I do it this way, intent. So now remember, I'm in the student display activity, which is the second activity that gets shown. That activity right there that's displaying the courses and the other information about a student. How does it know what student to display? Well, the main activity passed to it through its intent information. So intent gets serialized extra, whose key is students, and I've got if it's not null, so this is a tertiary operator. If it turns out that I didn't get it passed, then in fact I'm just going to create a new one. But if it did get passed, then I'm going to do student collection intent.get serializable extra of students. So that populates my collection, my being now the student display activity. And now I have to know what student I'm supposed to display. Intent.get a string extra of the selected student. All right, so the key here, selected, and students have to match the keys that they were set up with in the main activity. All right, so that's the way that we pass information from one activity to another activity, and the way that we cause another activity to be created and to transition from one activity to another. We looked at the life cycle methods that occur, and those life cycle methods would actually be called in both of the activities as we defined in that previous section of the course. Okay, so let's not even touch with the prepare adapter. This time, however, we do have, we implement the on create options menu. So notice that in this activity, we do have action bar buttons. You could say I should have picked out better icons for them. They're dark and they don't show up very well, but it is what it is. So if an activity overrides on create options menu, then in fact there will be menu items that are created, and they're done the same way as other layouts are. Student display menu is a layout, and that layout is kept inside of the menu resource folder. So here it is. So you can see I have three different menu items. One of them is an add menu item, which has an IC action add as a drawable. So there is added to this project several different IC actions. So here's the icon for adding, IC action add. Here's an IC action back. These would have been better if they'd been white instead of black, but retrospect is hindsight's 20/20. And then remove to remove, right? So there's three different action buttons. You'll notice that they're set up for having three different resolutions, screen resolutions, so that this will work display well on different screen resolution sizes. So I want to point that out. That creates those menus, menu items in the action bar. And then on options item selected, by overriding that, this activity is able to handle selections by menu items. In particular, one of them is the back, and here it is right here, r.action.back, _back, on option item selected, item get item, all right, action back. So action back, create a new intent. I put the students on that intent. I set the result, this.setResult to result OK. This is a constant that's available in the activity. And then I say finish. All right, so that tells this activity that it's done and that it has a result. The result is that I finished normally, and meaning that when it goes back to the main activity, that will cause it to go back to the main activity and cause this on-activity result. So not only have we looked at the mechanism for connecting, creating a new activity, instantiating a new activity and causing it to come into view, but also the way to pass information from the original activity to the new activity and from the new activity back to the original activity. All right, so those are that and the the simple adapter are the main issues that should be gleaned from this particular example. Okay, so I'm going to leave it at that at this point. We will look at, I would also like to look at the specific data sources that are provided by a expandable list view, but we'll do that in a separate video. That'll be the end of this one. Thank you.